Hi everyone, welcome to the Earth Science Regents Review podcast series created by Hommocks Middle School Earth Science Department. Today we're going to focus our attention on the layers of the atmosphere. Now, the layers of the atmosphere are very important to us because the atmosphere is essential for life to exist on the planet. Now, the atmosphere today is very different from what it was like 2 billion years ago. There are a lot of noxious gases like sulfur and methane in the atmosphere, unlike today, which is mostly nitrogen and oxygen. Well, those gases basically came through the violent volcanic eruptions that occurred during the early years of our Earth. That process, called outgassing, basically released a tremendous amount of noxious gases into the atmosphere. You'll notice that oxygen was not a major part of that early atmosphere, very simply because there was not a large abundance of plants during that time. Now, our atmosphere today is very important to us because it's essential for life to exist. Without the atmosphere, there's no oxygen, there's no life on the planet. We know that our atmosphere is broken up into multiple layers, and we'll talk about the 4 basic layers of the atmosphere. And we'll also focus on the fact that temperature is an extremely important concept when going from one layer to the next. And like I stated earlier, notice the composition is very, very different from the early atmosphere 2 billion years ago. Beautiful photograph of the atmosphere today with the white clouds. We're going to focus our attention on that layer where all the clouds are found. That's called the troposphere. We'll get to that in a second. And as we increase our altitude or we increase our elevation above the Earth, you're going to go from one layer to the next: troposphere, stratosphere, mesosphere, thermosphere. So let's jump into the troposphere, talk a little bit about it. So with this layer, it's going to be a layer that we currently live in. It's where the majority of our water vapor is found, and with that being said, that's where the majority of our weather is going to be found as well within our troposphere. Because we live, for the most part, close to sea level, we're going to have the majority of the troposphere, all the stratosphere, all the mesosphere, and all the thermosphere pushing down on top of us. So we're going to have the greatest atmospheric pressure found within the troposphere. As you travel up through the troposphere, you're physically getting further away from the Earth, so temperature is going to decrease. And that's evident when you look at mountain ranges that are high enough. Many of them tend to be snow-capped even in the summertime. Next layer up is what we call the stratosphere. Stratosphere is going to be super important to us because it's going to house what's called the ozone layer. The ozone layer is a special part of the stratosphere that protects us from the ultraviolet radiation from the sun, which is currently shortwave radiation, which scientists believe causes high cases of skin cancer. Now, as you travel up through the stratosphere, temperature actually goes up. Even though you're getting further away from the Earth, it goes up because that ozone layer is absorbing a lot of the sun's energy, causing your temperature to go up. Now, here's a picture of the ozone layer, the thinning of the ozone layer. A lot of people call it a hole, but it's actually a thinning of the ozone layer over top of Antarctica. Now, currently, CFCs, which are chlorofluorocarbons, have attacked the ozone layer and have actually thinned it out over top of Antarctica. Since the banning of CFCs, the ozone layer has actually started to repair itself, is actually thickening over top of Antarctica. The next layer up is what we call the mesosphere. Now, the mesosphere has some of the coldest temperatures in the atmosphere, and as you travel up through the mesosphere, temperatures drop dramatically, very simply because of the layer above it, which is called the thermosphere, and we'll talk about the thermosphere in a second. Okay, this is pretty much where the layer where all your meteorites or your shooting stars are going to burn up as they enter our atmosphere. Now, the reason why the mesosphere is so cold is because the thermosphere is going to absorb a tremendous amount of the energy from the sun, gamma rays and X-rays specifically, those really nasty rays from the sun, really, really short wavelengths, really high frequency, very dangerous waves from the sun. They get absorbed by the thermosphere. So this tends to be some of the hottest temperatures in the atmosphere because your temperature is going to go up through the absorbing of these rays. And many times, if you have an opportunity and you're lucky enough to see the Northern Lights or the Aurora Borealis or the Australis Borealis in the southern hemisphere, the southern lights, what will happen is those are going to be taking place in the thermosphere. So those are basically your 4 basic layers through the atmosphere. A couple characteristics. You want a little bit more information about them, please go to your reference table. Now, where one layer ends, the other one's going to begin, and it's all temperature dependent here. So where the troposphere ends and the stratosphere begins, that's what we call the tropopause. You get a very, very distinct boundary in temperature differences between the stratosphere and the troposphere there. So the boundary between those 2 layers is what we call the tropopause. Where the stratosphere ends and the mesosphere begins is what we call the stratopause. And where the mesosphere ends and the thermosphere begins, that's what we call the mesopause. Okay, so make sure you know the difference between the spheres, which are the layers of the atmosphere, and the pauses, which are the breaks. Now, where one layer ends and the other begins is all temperature dependent. If you go to your reference table, you'll see that relationship. Now, you do have a couple atmospheric relationships with the increase in altitude above the surface. So water vapor, because water vapor is solely concentrated for the most part in the troposphere, as you increase your altitude, as you go up to the atmosphere, water vapor content is going to decrease. Because your greatest pressure is going to be at sea level pressure in the troposphere, as you increase your altitude, your pressure decreases. Both of those are going to be what we call indirect relationships. So very important to understand those. Again, those relationships are all found in your reference table. Now, you do have some variables that we're going to talk about in this unit regarding weather. So obviously some of the atmospheric variables are going to include temperature, pressure, wind speed, wind direction, humidity, and dew point, just to name a few. Now, in order to understand a lot of these variables, you need to have some instruments. And some of those instruments that you're going to use throughout the course are going to include a thermometer, a barometer. Thermometers are going to measure temperature. Barometers are going to measure pressure. There's a rain gauge going to measure the amount of precipitation. There is your sling psychrometer, which measures humidity, specifically relative humidity and dew point. There's a wind vane or a weather vane. Okay, it's going to tell you wind direction. And then finally, an anemometer is going to tell you wind speed. So those are just some of the variables that are going to be measured with some of these instruments. So with that being said, layers of the atmosphere is completed. We'll talk to you soon. Bye-bye.